Okay, right, so Android application development. You've had 2 labs already on Android. So how was your second lab? Do you manage to get the Java sorted out and get your head around the syntax? Because just like with Objective-C, once you get your head around the syntax, everything else becomes a lot easier to work with. You're doing class methods, instant methods, constructors, private variables, haven't you? The lot now. So you know what you're doing, potentially. Okay, so we're going back. This is the last session where we're working with single view applications. We're going to look at different controls and how we use them. Next week, we're going to start doing multiple screens, multiple views in the application, just like we did with navigation controllers in iOS. So this is the chance to get your head around all the different controls. But we're going to look at 3 things today. We're going to look at something called resource files, okay, which is how we store information about the app. We're going to look at listener syntax, how we listen out for events. And we're going to look at some of the basic controls you can play with and just get you started on those. But the thing with Android, there's lots and lots and lots of different controls you can use. I'm only just scratching the surface on this. Okay, resource files. You've probably seen some of these, haven't you? Yeah, strings is already there. I think styles is there by default. And dimensions, I think, is there, if memory serves me right. Is that right? The other ones, you just right-click and add a new file. You can add these, and you can call the files anything you want to anything you want to call them. And I'll explain how you reference them once you've created them. And the idea is all the resource things like measurements and numbers and colours and strings, and all this information is stored in these files. So rather than having concrete measurements in your application, you can store them in these files and you can modify them globally by changing the content of these files. So for example, the strings file is where you store the text that goes in the app. So if you want a translation into a different language, you can email that strings file to somebody and they can email you back the translated version of it. And then you just drop it into the application. So it's really nice and simple. There's actually more than this, more than these files. These are the ones you're probably going to be using. And when you created them, there's 2 ways you can get the values back out again into your application. If you think about it, sometimes you need to get values out in XML, in the views. If you want to put like a label on your view, you need to retrieve values inside a view. But sometimes you need to access them in Java, don't you? Things like measurements and constants and stuff, you want to access them in the Java code. The clever thing is, once you've put them in there, you can access them really easily. If you look at the text, look at the top one. First of all, look at the text property, Android text. See that @ sign? That's the resource. And the next bit is the name of the resource file. So @ string is in the string.xml file. Look down a couple of lines, you've got @ color. That's the color XML file. So you can reference, and when you get in there, the value that's in there is after the /. So you can put anything you want into these files and pull it out again into the application. Now, accessing it in Java is a bit more difficult. The way it works is when you compile your Java code, it creates a special class called R. Okay? R for resource. You don't do anything about it. It's automatically generated for you, this special class called R. And every single object, every single resource is referenced from that R file as a class method or class property. So you can see, look, res.get color, R, there's my class, dot color, that's for my color file, dot opaque_red, which is the key that's in that file. So can you see how you can put these values into these XML files and then pull them out in the layouts and also pull them out in your Java code? And it's always a good idea, that's a hint to say do it, to make sure you always put resources in those files, because then you've got global control. Let's imagine in the dimension file, you put a measurement for the margin around your controls, between the controls and the edge of the screen. If you don't like it, you can simply go to the dimension file, tweak that value a tiny bit, and it updates every single view with that new dimension. So I won't expect to see any numerical values or strings referenced directly in your Java code or in your layouts. Get everything in these files. Okay? So let's have a look at a simple example. There's dimensions. Now, they all start the same way. Because they're resources, you always have to have a pair of resource tags. That makes sense, doesn't it? It's XML, so you have your XML namespace. You have your resource key tags, and then underneath it, can you see I've got a dimen tag? And I've got a name attribute. Well, that name attribute is what I reference in my XML and in my Java files. And the value I get back is the value inside the tags. Yeah, the text value inside the tags. So it's an incredibly simple structure, isn't it, to this to these files. So you can see, if I said r.dimens.textSize, I'd get 24 dp out of it. So a really simple way of referencing these values. In fact, it's one of the great features of Android that you've got this lovely sort of centralization of these resources. Look at the integers. I've created 2 constants in my integers file. Again, XML and resource tags. I've now got an integer tag. And I've got the name of min and max. And because I've made them as constants, I want to refer to them as constants. You normally capitalize constants, don't you? So I simply make the name attribute capitalized. And I've now got 2 global constants across my whole project. And I can reference those anywhere I want. Okay, let's have a look at another one. Strings. This is the one you'll change most often. Same schema. You've got your resources tag, and now you've got a string tag. And you've got a name tag just as before. So r.string.app_name will give you controls. r.string.toggle will give you toggle button. And the idea is if you want an internationalized version of your app, you simply email this file to your translators, and they simply replace the contents of those tags with whatever the alternative is. Having said that, you do get caught out sometimes on this. If you want a German version of your app, you could have a few issues. Because you've got to remember that different languages have different lengths of word to say the same thing, and I've been caught out with this before. So in German, they tend to string a lot of these words together and make these very long words. So you've got to make sure you've got enough space on your buttons, for instance, right, to display what you want to display. So this is really, really cool, isn't it? You can store all your resources. There's colours, look. Remember my opaque red? r.color.opaque red. Well, there's the R was the class, wasn't it? The colour is my colour tag, and the opaque red is the name. And in theory, you can mix and match all these in different files. You could put all these resources in one massive, huge file. Does that make sense? Because all that matters is the XML tag names. Because you've got colour, going back, you've got string, you've got integer, and if I go back there, dimen, there you are, look, you see, r.color, string, yeah, these are the tag names. So you could combine everything into one massive XML file, and that'd look a bit messy, wouldn't it? You could do the opposite extreme and break it into lots of smaller XML files. You could have different XML files for different parts of the application. How you divide things amongst files is entirely up to you. So finally bust. No. Let's go through them. Right, so that's all about resource files. And the important thing is you organise the resources in the most appropriate way, the way you want to organise your resources. As long as you use the correct XML tag names, everything's fine. You can also have arrays. There's an array tag. So you can create, if you nest like a list item with lots of items in a UL tag, you can have an array tag with a name and have lots of items with the keys inside that array tag. So you can do all sorts of structures, data structures using XML. So that's how I want you to organise all your resources. Now, I'm going to do a little tiny bit on listener syntax. You've done this before because you did it in the first assignment, the first lab, didn't you? Where you had the button, the on-click listener business with the button. This should just be tidying up your understanding. In the example I gave you, I made the class implement the listener. Remember that one? the class implemented the correct listener, the on-click listener. And then when you said set on-click listener, you specified this, didn't you? And then you could implement the method inside your class. However, anyone like JavaScript? Anonymous functions. Remember those classic anonymous functions we had? Function is a parameter. You can do exactly the same or virtually the same using Java. There we are. So if you're used to JavaScript, this will look completely comfortable. If you hate JavaScript, this will be giving you nightmares. So let's have a look at this. So the great thing about this is I can create my button with local scope. So I haven't got to have this global button object. Because as soon as I create the button object, I'm assigning the click handlers to it immediately. I don't need to have that persistence. So if we look at this one, I create my button, find view by ID, and then straight away I say my button dot set on click listener. Again, you've done that before. New view dot on click listener. Okay. Now think about how this is working. We're creating, instead of using an instance method to create an on click listener, we're creating using the class method of the view class. So we're saying, just give me an on click listener. Okay, it's anonymous. We're not declaring a separate function for this, a name function. And all I've got to do is put all my listener methods inside that structure. You see that? And that's how in one fell swoop I can set the on-click listener and define my handlers all at the same time. Sometimes useful when you've got lots and lots of different controls because you can group things together, can't you, quite nicely. But some people just don't get comfortable with that idea. And so either system will work. The benefit of this system is scope. You've only got locally scoped variables, but the button scope can be seen inside the handler. So even though you declare button find view by ID, for instance, you can still see that button object inside that on click. Just like in JavaScript, how it cascades, the scope is visible. So that's an alternative way that you can implement your on click, implement any of your listeners. And how you do it is entirely up to you, your choice on this one. Personally, sometimes I use one method, sometimes I use a different method. Depends how I feel or how complicated the code is, yeah? But that's the alternative. Okay, so let's just very summarise this. Benefit of this is you don't have to figure out which button's done the clicking, do you? Because each button's got its own set of handlers. So you haven't got to have if v equal to, my button, then do something. The downside is, because each button has to have its own handlers, you can't recycle any of your handlers. You've got to declare a separate handler for every single button on your screen. And that might decide how you're going to do, which method you're going to use. So the pros are, you've got local scope and you haven't got this query about what's being clicked. The downside is you've got to create a new handler for every single control on the screen. There is, however, I'll tell you this now rather than the first week, a cheat. Most of the time you're doing clicks, aren't you? You're detecting clicks. 99% of the time it's going to be clicks rather than swipes or gestures or anything else. Well, if it's a click, you can put the name of the handler in the XML. How you wish I'd shown you this 2 weeks ago. So if it's you've got an Android on-click attribute of any control, and you simply specify what the name of the method is that's going to handle that click. That's easier, isn't it? So for on-click handlers, why not? Then all you do, look, in my main code, as long as I create a method with the correct name that passes a view and returns void, I can just create the method. There's no implementing, no faffing around with nested methods, nested functions. Job done. I can even recycle the same click event, can't I? Amongst multiple controls. I just specify the same event in my XML, in my layout file. So lots of the time you'll simply build your handlers into the XML. And that's much easier, isn't it, than having to go through all the palaver. But it only works for on-click. No other event is handled this way. So they obviously thought, how can we make it easier? And they just implemented this on-click. Okay, so you're happy with that? 3 different ways of handling click handlers, 2 ways of handling anything else. All right, basic controls, a sort of bestiary of the different controls that you've got available to you. And we'll do a very quick tour. They're what I consider to be basic controls. I've excluded things like list views and tab controllers and all these sort of things. Just the basic stuff. So text views, yep, where you can just like labels. Edit texts are your text boxes, aren't they? Buttons, toggle buttons. Have you played with those yet? Have they got toggle buttons? It's just a compound button where there's a little light on it. And when you press it once, it's on, and then again, it's off. So it's just a subclass of button. Checkbox, which is actually a checkbox and a toggle button, believe it or not, share the same parent. Think about it. Checkbox and toggle button are actually the same thing. They just look different. Progress bar, you know, a little bar going across like we did with iOS. Seek bar, which is the scrub, the sort of slider, side with your finger, and a rating bar. Seek bar, rating bar, progress bar, again, all related to each other. Right. The way it works with the properties. Have you noticed that the properties are grouped into different sections in the properties window? It's always the same order. You've got your ID property normally at the top, unless you've been messing with the order. Then you've got your layout properties, like your margins and your relative layouts and stuff. Then your text properties, you know, fonts and text and colours and those sort of things. And then finally, at the bottom are anything related to the superclass, because obviously if it's a subclass of another class, you can change those properties as well. So just get familiar with that properties window. It'll save you a lot of time. There's my text view. Now, the key control with all of this is Android.view.view. That's the super class of all the controls that sit on the screen. Every control is related to Android.view.view. And as you can see, the text view is simply a direct subclass of view.view. And the most common properties you set, obviously ID, text property, appearance, colours, yeah, those are the usual things you set. Pretty obvious stuff, really. Now, look at the edit text. Look at the hierarchy, the object hierarchy for it. Where does it sit related to text view? So it's just a direct child. It's a direct child of text view. It's just a text view which can be edited. So they've taken the text view and added some properties to allow you to edit the text when it runs, and that's it. So all the properties you set for text view, you can use the same properties for edit text, can't you? Because it's a subclass of text view. Okay, remember this. Remember how object-oriented code works, inheritance works. Text size, autocorrect's quite cool. Come on. Okay, let's go through them. Text hints. You know, when there's no text in the edit text, you have a little sort of grey writing. That's useful. Input type. Input type is what keyboard you get. How do you interact with it? So input types, look at all those. So classic ones are text multi-line, which means you can have lots of lines of text in there, so the enter key takes you to the next line. Autocomplete, which sets the autocomplete to the dictionary. Password, which turns it into dots. But there's a whole load of them, look. Postal address, password, email address, email subject. So you can customize what keyboard appears when the person clicks in that box. Okay, and that, in a way, is your validation, isn't it? That's your form validation. So only the correct keys appear when the person opens the text box. So that's worth having a look at, all the different options. You can tick multiple ones of these, but obviously some will cancel each other out. Now, key presses. It's very handy to detect stuff being entered. So you can sort of do validation on the fly or whatever. Now, I'm going to show you the original way of doing the handlers. But remember from the previous section, you can change this to have anonymous functions. So instead of adding an on-click listener, like we did in week 1, you add a text change listener. Makes sense, doesn't it? And obviously, if you're going to do it the first way I showed you, you need to implement text watcher, which is the interface. And text watcher is how you can respond to these key presses. And it only has one callback method after text changed. Okay, after text change is the callback. And look at the parameter. What would you expect it to be? Look at the data type of the parameter of after text changed. What's odd about it? What parameter would you expect to be sent?
String.
You'd expect a string, wouldn't you? Thanks, Tim. You'd expect a string. The reason you're not sent a string is because when you type in stuff in, a string is immutable. You can't change the string. You have to create new strings. So a subclass of string is an editable. And because you're constantly changing the values of it, it's storing the text in an editable object, which allows it to be changed. An editable and a string, they're pretty much interchangeable. Occasionally you get a bit of a faff about it, in which case you just call toString on it, the toString method. That turns it into a fixed string. But normally you can chuck an editable wherever you want a string. Why can you do that? Think about inheritance. Because it's a direct subclass of string. So generally, you can just throw an editable wherever you'd expect a string, because it has all the same string properties. Okay, and you can see, after text changed, I can get length, I can log things, yeah? And that's the most useful callback for an edit text. Okay, buttons. Right, look at the object hierarchy here. What do you notice? Yeah, it's a text view, it looks different and responds to events, responds to clicking. That's it, that's all a button is, isn't it, really? If you get rid of all the graphics inside, it's simply a label which can be clicked. And if you look at the object hierarchy, that's exactly what you get in here. And obviously the special thing you set is the on-click, isn't it? As we've just been talking about. But all the text view properties apply to a button as well, because it's a subclass. As opposed to iOS, where the button is different, isn't it? The button contains a label, doesn't it? The button contains the label, and you have to then access the label inside the button. In Android, because it's a direct subclass of the text view, it is a text view effectively. On-click event. I think we've done this to death, haven't we? Yeah, we've done on-click. I've left that in purely as reference, so you've got one presentation with all this in. But I'm guessing if you haven't worked that one out by now, you're probably falling behind. Toggle button. Here's an interesting one. The toggle button. I mentioned this briefly before. Look at the object hierarchy again. That's always the best thing to do when you first see a control. Where does it sit? Where's it, Benedicta? Where's it sitting?
I can't even see where the toggle button is.
Hmm?
I can't see where the toggle button is.
There's a toggle button.
Oh, okay.
Where does it sit inside the hierarchy? What's its parent? Compound button. Right, and what's the compound button's parent? Button. You can kind of see how this is working, can't you? So a compound button is where you've got more than one control inside the button. And effectively this has got a label, hasn't it, in the button? You've got a label which lights up or doesn't light up, and a button. And this is the first example of a compound control I've shown you. And all this does, this simply has a checked property. And the check property returns true if the button's on and false if the button's off. And that's the key change between that and the standard button. So it allows you to toggle a value on and off. And so that and the checkbox, like I said before, are practically identical, aren't they? They look different, but they handle the same way. So the compound button is where this toggle comes from. Okay, not the toggle button. So any class that inherits from compound button is going to have this toggle property. And that's why checkbox also subclasses compound button, because it then inherits this checked property again. So compound button is where you get the checked, the on and off bit. And there you are, look at the hierarchy for checkbox. In fact, I'm going to treat them both the same. I'm going to show you them both at the same time because they're identical in terms of how they behave. Yep, you've got checkbox again. And it's a subclass of compound button again. That makes sense, doesn't it? You can see how this fits together. Unlike iOS, it's important that you understand the inheritance that's taking place with these different controls, because that will give you ideas of how you can use them and what properties they're likely to have. So as you can imagine, a checkbox has all the properties from object view, text view, button, compound button, and checkbox in the properties list, which is why it's really important to get your head around how the properties list is organised. Otherwise, you'll be hunting for stuff. Hundreds of properties. Now, this is the key. On check change listener. So this is the library you have. This is the interface you have to implement the toggle feature. Okay, can you see that one? And you can see I've literally done both. I've got toggle button and checkbox in the same bit of code, just to show you how it works. And you can see, look, public void on checked change. You've got two parameters. You've got the button itself. Notice how it's a button you get past. Think about it. That's what you care about, isn't it? They're all subclasses as a button. And you get the Boolean true or false. Is it on or off? So from there, it's very easy, isn't it? You can say if checked, yeah, then you can switch it on and off. So a toggle buttons and a checkbox, pretty much the same thing. They just look different. Progress bar. Now, looks suspiciously like a certain control you've done before, doesn't it, in iOS? In fact, isn't it called UI progress view? Yeah, it works in exactly the same way. So this is a direct subclass of view because it hasn't got a clicking thing, has it? You can't tap on it to click it. You can't edit it. So therefore, it's a direct subclass of view. And as you can see, I've got styles. If you change the style, you can have like a rotating one. You know, the sort of progress thing. You have a rotating thing on the middle of the screen. That's a progress bar, believe it or not. It just hasn't got the style set to style horizontal. You've got a max property. What's the maximum value? And you've got a progress. Okay, so pretty simple stuff, isn't it? And all you do, there's a method called set progress. There's no listeners, are there? Because there's no events it responds to. So they've simply got this property, set progress, and you can set the progress to whatever you want to set it to. Okay, seek bar. Now look at this one. Look at the hierarchy here. Look at the class, the inheritance going on here. It's actually underneath, it's a subclass of progress bar. So in other words, anything you do to progress bar, like set progress, for instance, you can do to a seek bar, because it's a subclass. So here's a nice one, look, there you are, seek bar. Max and default. Default is the value it's set to start with. But this time, they get longer, these interface names. Not quite iOS length, but they're getting quite long. So this is on seek bar change listener. Okay, that's the interface we have to implement. And you've got 3 callbacks. Not 1, 3. You've got on progress changed. That makes sense, doesn't it? So if the value changes, you move the bar somewhere else. But you've also got on start tracking touch. In other words, the person's put the finger on, they started moving, you get one event fired. When the finger comes off, you get another event. So you've got an event when they touch, a series of lots of events fired as they move it, and an event fired as they take the finger off. Okay, so 3 different callbacks there, 3 different event handlers. And that's all there is to it, really. I mean, most of these controls are sort of, one-trick ponies, aren't they? Hopefully, do one thing well. Rating bar, now look at this one. Look at the parent class of rating bar. What do you notice? Yeah, progress bar and add bar, but what was the last control we looked at? Seek bar. Seek bar and rating bar are the same thing. A rating bar is simply a seek bar that displays the position as a series of stars. That's it. That's the only difference. Well, there's a slight difference that you can actually, your values can be floats now. Because obviously it's stars and half stars and quarter stars and everything else. You can see here that I've set the step size to 0.2 and the rating to 2.4. So this takes floats rather than integers. But where you've got a seek bar, you could put a rating bar instead with minor changes to your code. So nice and sort of simple, didn't like, nice simple bit of code there. And this one, guess what? On rating bar change listener. Okay? And the same thing, except of course on this one, you've only got the on rating change. You haven't got lift off and lift on. You haven't got those callbacks. So, pretty good timing there with the. So we've covered resource files, which you need to get really comfortable with because everything you do is going to use them. We've covered 3 different sorts of listener syntax, especially if you're using on-click. And we've also covered just the kind of basic controls to get you started in your Android programming. There is a lab task this week, which is similar to what we did with the iPhone. Remember we typed the stuff in, it counted how many characters the word, the little bar. From next week, you should be ready to start your first assignment when we start doing multiple views. At that point, if you haven't started your assignment already, next week is the time to start working on this on the first assignment. Okay? Now, there's no tricks to work out what the assignment's about. Yeah, rewind 12 weeks and you're in exactly the same position, won't you, with the iOS one. So I would start your assignment next week. Absolutely, start designing it, start getting the icons and everything else together. In fact, you start that this week, couldn't you? The splash screen, though, I'll talk to you briefly about splash screen because that's going to cause more of a challenge for you. The splash screen is more of a challenge because you can't put a graphic in to act as a splash screen. The way you get a splash screen to work is you load a view on top of your first screen and you have a timer. And when the timer runs out, you get rid of the view. I'll talk to you more about that next week when we start talking about multiple views. But you have to do it that way. There's no nice, easy way of just dragging a graphic in. And the other problem you've got is some Android devices are this big, and some are this big, and some are this big. So getting a splash screen that kind of works could be challenging. So you need to play around with different dimensions and sizes to try and get it working. So it's not quite as easy as iOS, where you just had 3 graphics, didn't you, for different size screens. Any questions? Yeah.
You know, on the previous slide.
Which one? Do you remember?
It has to do with the seek and the rating.
You mean with the apps?
Yeah.
This one? That one?
When you implement it, why does it take string value instead of float or integer?
Where am I looking?
Public voice on stop tracking touch.
No, it doesn't. It takes a seek bar. It takes a seek bar.
The string value, string dot value.
Oh no, I'm just logging it. I'm just saying string value of seek bar get progress. What I'm doing there is because it's a float, sorry, so it's an integer, I want to display it. I'm grabbing the value, getting the value of, turn it into a string, I store it in a variable and then just log it. To be honest, just to make sure there's a bit of space between the opening bracket and closing bracket, if I'm being honest. Yeah, that was all it was there for. Okay, and that's another good bit of code. If you want to convert floats and ints and things to strings to display them, you've got string.value of, and you can shove anything in there and it returns us the equivalent string. That's another reason why I put it in there. Okay, so hopefully that will help. And I'll leave those contact details if you're interested in that proposal. If you're not interested in the proposal, I shall set Tom on you. Tom Donnelly, remember 305? Yeah, oh God, yeah. Okay, cheers guys, thanks very much.